Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 12B Part 2 assignment. First one we're going to take a look at here is number 14. Consider a rectangle inscribed in a circle of diameter 10 centimeters. In the diagram alongside, suppose BC equals X centimeters. Okay, and we also know that this diameter here is 10, try that again, 10 centimeters. Okay. It says for part A, show that if the area of the rectangle is A, then A squared equals this here. So first thing we want to do is find the area of the rectangle. To find the area of the rectangle, we need to know the base and the length, right? Length times width. Okay. So we know that this is X. We need to figure out what this is. So if you look at this triangle right here, so we'll draw D to C to B. We know that this is X, that's a right angle, and that this right here is 10. What we really need to know is we need to know what that is, right? So we can simply do A squared plus B squared equals C squared. So in this case, X squared plus question mark squared equals 10 squared, right? Because the hypotenuse is always whatever, that's the C squared part. So we get X squared plus question mark squared equals 100. We want to figure out what question mark squared is, so we want to subtract X squared. Right, so we get question mark squared equals 100 minus X squared. And we got to square root that to get the question mark all by itself, so that gives us the square root of 100 minus X squared is what this is going to be, right? But the square root of that whole thing. So if we're looking for the area of this thing, we got to multiply length times width. So this is for part A. And then let's see, we're a little out of room, so we'll keep working over here. So the area would then be X times 100 minus X squared. And that's really the square root of, right? So we could just write it like that. That should work. Okay, so that's our area. Okay, and then now it says, if that's the area, find area squared. So that means we're going to square both sides here. So area squared would be, that's going to give us an X squared here. And then this 100 minus X squared and the square, those are going to cancel out. So we have X squared times 100 minus X squared, right? So if we distribute that X squared through, we get 100 X squared minus X to the fourth, which is exactly what they're looking for right there. Okay? For part B, find d over dx of area squared, and hence find the value of x which maximizes a squared. So that means find the derivative of this thing that we just had, right? A squared equals 100 x squared minus x to the fourth, so a squared prime is going to be 2 times 100 is 200. Subtract 1 from that, so it's 200x. And then 4 times 1, no, 1 times negative 1 is negative 4. X to the third. So there's our derivative, right? So if we want to find the value of x which maximizes a squared, we've got here's our derivative function. If we're looking for the maximum of a graph, right, that's when the slope of the tangent has a slope of 0. So that means that this derivative function, we want to set it equal to 0, right? 200x minus 4x cubed. One thing to make our life a little bit easier is let's divide everything by 4. And that gives us 0 equals what? 50x minus x cubed, right? And then we can factor an x out of both of those, and we get 50 minus x squared. So x is going to have to equal 0, right? Because x can equal 0 here. Or when we get 50 minus x squared equals 0, right? Add x squared to both sides. 50 equals x squared, and we square root both of those, so x can equal the square root of 50, or x can equal 0 in this case. If x is 0, then it doesn't actually make a rectangle here, so we're going to get rid of that and go with that. This would be maximized when x is the square root of 50. Okay. And then part C, hence find the dimensions of the largest rectangle which can be inscribed in the circle. So if we know x has to equal 50, we can figure out what the other sides have to be. So one side is the square root of 50, and the other side, the length here, so here's part C, length is going to equal the square root of 100 minus the square root of 50 squared, right? So the square and the square root cancel out here, and we get length equals the square root of 100 minus 50. So length is the square root of 50. So basically it's going to be a square with side lengths of square root of 50. So you can just leave it as the square root of 50 times the square root of 50, or if you want a decimal answer, you can do that too. I just kind of want to at least look and see what the square root of 50 is, so I can like kind of picture it. 7.07. Okay, so root 50 times root 50 is going to be our dimensions, or 7.07 times by 7.07. Okay. Okay. That's all we have for 14 there. Let's take a look at the next one. 16, at 1 o'clock, ship A leaves port P, sails in the direction of 30 degrees east of north at 12 kilometers per hour. Okay. So let's take a look at that. East of north. That's kind of an interesting way to describe that, isn't it? Okay, so what they're really trying to say here, directions of 30 degrees east, here's due north, and they're saying 30 degrees east of that, so to the right here. So that means that we've got this 30-degree angle right here, and this is the direction that the ship is sailing. Okay. At the same time, ship B is 100 kilometers due east of P. Right, so this is port P, by the way, here. In fact, let's draw this big out here so we get a better idea what's going on. Okay, so here's port at P here, and we've got this ship heading off at 30 degrees. Never eat soggy waffles, right? 30 degrees, this ship is heading off. And then it says ship B is 100 kilometers due east of P. So we know that this is 100 kilometers here. Okay, and it's sailing at 8 kilometers an hour towards P. So it's basically heading straight back towards P. Show the distance D between the two ships is given by this here, where T is the number of hours after 1 o'clock. Okay? Okay, I had it going due south. It said it's due east, so I changed it here. So the ship is starting over here due east, and it's heading towards port, and this one's starting at port and heading at 30-degree angle east of north. Okay, so it's looking like this. So when they're starting, it's here and here. Now, as they move along, the ship B is going to be moving in closer, and then ship P is going to be going out here. So now it's really going to end up, and if we leave port P here, now we're going to end up with this triangle looking thing here. And again, as we move on in time, this is going to go this way and this is going to go that way. So it's going to look more like this, and it's going to kind of keep moving. Okay, so what we're trying to figure out at all times is show that the distance between the two ships, question mark, we should probably change those into D's instead, right? So those distances here, it should be given by this wonky formula here. And here's where they're coming up with that from. So nothing in here is guaranteed to be right angles, because this is a 30-degree angle here. So this should always be a 60-degree angle right here. But that's pretty much all we know. So here's what we can do. We can use the law of cosines, right? Which is a squared equals b squared plus c squared minus 2bc cosine a. Everyone remembers that, right? Okay, so there's our law of cosine. So we can use that to try to figure out what our distance is at all times. Okay, so we know that this distance here should simply be, let's see, we're starting at 0, so it should simply just be 12 times t, right? 12 kilometers for every hour. That should be how far that's going to be. So that's going to be this triangle here. So let's maybe just, I'm just kind of going to redraw it down here. I know we got a whole bunch of triangles going on here, but this should be 12t. And then the orange piece of the triangle here, let's do this. Start with a little darker color there. We know that we're starting at 100, but then we're moving 8 kilometers closer to port at all times. So that would simply be 100 minus 8t. So that's going to be what this length is here. And again, we know for sure that this angle here is going to stay at 60 degrees. So then what we're looking for is this out here, our distance of the two ships away from each other. Okay, so hopefully this makes it make a little bit more sense. Okay, so if we use our law of cosines here, what we're looking for in this case is the d. So that's going to be our a squared. So we'll do from this over here using our law of cosines, sorry, coming down here. So we get, in this case, d squared is going to equal the other two sides, so that's going to be, say, 12t squared plus 100 minus 8t squared minus 2 times 12t times 100 minus 8t, all times the cosine of a, which is 60. So it's this big mess here. Okay, chances are it's going to end up equaling this. So let's hope that it does. So let's just start simplifying and see what we get. So 12t squared is going to be 144t squared. And then this here, if we've got to FOIL this thing out, right? 100 minus 8t. 100 minus 8t times 100 minus 8t gives us, if we do FOIL, however you want to do it, that's 1 with 4 zeros after it, right? 10,000 minus 800t minus another 800t. Negative times a negative is positive. 8 times 8 is 64, and t times t is t squared. So this is, I'm going to write it with the t squared first. So this is plus 64t squared minus 1600t, right? Because that's what these two together are, plus 10,000. And then we got to multiply this here all together, all times cosine of 60, right? Okay. So let's do this. I'm going to do negative 2 times 12 is negative 24t. And we got to multiply that by 100 minus 8t times cosine 60. So this is all going to stay the same. I'm just going to simplify this over here. Negative 24t times 100 is negative 2400t. Negative 24 times negative 8 is positive. And let's see, what's 24 times 8? 192. 192 t times t is t squared. And then this whole thing is being multiplied by cosine of 60. So let's see what cosine 60 gives us. Make sure that your calculator is in degrees. And we will do cosine 60, which gives us half. So this is times 0.5. So we're going to take half of all that. So that's going to be negative 1200t plus, let's see, 192 divided by 2. 96 t squared. And then we still have all this stuff here too, right? So d squared equals 140. Oops. 44t squared plus 64t squared minus 1600t plus 10,000. Sorry, I'm kind of started writing up at an angle here. So this is all the stuff we got to gather together here. So d squared equals, we got negative 144t and 64t squared. Sorry, these two together. So let's start adding this stuff together. I'm going to do it on the calculator just to make sure I don't mess it up. 144 plus 64. So that takes care of those two t squareds, and there's another 96 t squared plus 96 t squared gives us 304 t squareds, right? And then we got negative 1600 and negative 1200 is negative, what, 2800 t. And then we got plus 10,000. And that's what d squared is. So if we square root both sides, d equals the square root of 304 t squared minus 2800 t plus 10,000, which I'm going to look back up here and pray that it's the same thing as that. And look, there it is, 304 t squared minus 2800 t, so forth and so on. So we got that part of 16. So we showed that that's where that came from. So I know that it looks super terrible and awful. The big thing is just figuring out that you're going to use law of cosines, and probably the bigger piece is really trying to figure out that this here is what your triangle is going to end up looking like here, and that's why we use law of cosines. So I really should have showed you the triangle first and say, oh, look, we got these two sides plus this angle in here in the middle. We're not guaranteed of any 90-degree angles, so let's use law of cosines. Okay? Okay, let's take a look at the next one. This is number 1 from the next page over. When a new anesthetic is administered, the effect is modeled by this here, units, where t is greater than or equal to 0 is the time in hours after the injection. Graph E of t using technology. All right, I'm all about using technology. So y equals, just graph this on our graphing calculator, right? 750. Now t is going to be our variable, x, and then e is actually a number, so that we should somewhere on here have an e to the x. There it is, right there. See that up above the ln, there's our e to the x. So we want to do second e to the, and it says negative, don't push subtract, make sure you do negative 1.5, and that's our x again, right? I'm going to put that in parentheses there, and I think that's it, right? And of course we'll do, say a zoom standard, and this is pretty well guaranteed to not show up anywhere on there. Oh, look, there it is. It's on there somewhere. So it looks like it starts way up there and it comes down here, and it's just going to go right along the line here. Okay, so we actually did see it on there. T is greater than or equal to 0 is the time in hours after the injection. Graph E of t using technology. So I might just change my window here to get a little bit better idea of what's going on. So we can tell, sorry, back here by the graph, we're not going to need anything negative over here, which wouldn't make sense anyway, because that's when time would be negative. We don't have negative time. And then the effect is modeled by blah, blah, blah. Good, high probability that it's not going to have a negative effect eventually, like have an inverse effect. So we're probably just going to need the positives of each one. So I'm just going to leave in negative ones just so I can see where you can put 0 in there, but so you can see where the x-axis is, actually the x-axis, and then up to 10, I'm going to just, not 120, I just want to put it up to, say, 20 instead of 10. And then, oh man, I messed this all up. Negative 1 up to 20. That's what I'm trying to do. And then our y, I'll maybe put a negative 1 there just to see if it ever happens to cross. And then we saw that it started from way up there, so I might put my max at, say, 100 and see if that changes my graph much. So there it is. It starts way up here, and then it comes down here, and it just basically turns into 0 here eventually. Okay, so graph E of t using technology done, hence draw a sign diagram for E prime of t. So basically we want to figure out when this thing's going to cross the x-axis, right? So we can do second trace, how did I do that? Second trace. We want to figure out when this thing is a 0. So we do 0. And then left value, we want to make sure that we know that it starts off positive and then it may eventually turn to negative. So it's positive here, so we're okay. We'll push enter. And then we're just going to want to push over and over and over again until this hopefully eventually turns into a negative. Look, this is getting really close to 0, but I don't know if this is... It looks like it's just coming down closer and closer to 0, but it does not look like it's ever going to cross. Okay? Now, this is not going to cross, but apparently I've done something wrong in here because this is supposed to look a little different. It's supposed to look like that with our axes. So I'm going to see what I can do to fix that, make it look correct. Okay, I found it. I just had to change my window because basically we were looking at this down in here. It wasn't going up high enough to see that it actually goes up like that. So here's what I did. I just changed my window from -1 to 20 to -1 to 8 for the X. You could change that. 10 would be fine too. And then really the big thing that made a difference was I made my Y max instead of 100, I made it 200. And that's what gave us this graph here. So, sorry. And then the sign diagram doesn't have anything to do with it crossing the x-axis. Remember the sign diagram, and I'm saying remember as in remember Mr. Stansbury. Sign diagram is when is it going up versus when is it going down. So we want to figure out, or for our sign diagram, we want to figure out this maximum point up there, right? So we could just go through and do second trace, and we can calculate the maximum, right? We have to scroll over until that gets all the way back over before it's hit the maximum, and then we'll push enter. So it's before the maximum there, so I'll push enter, and I scroll over until after it gets past the maximum. It's after the max there, and it gives us that max point there is 2/3 and 183.9. 0.667. 183.9, I think, was that max point. Is that right? 183.9. Okay, so draw a sign diagram for E prime of t. So that means the spot at the maximum is 2/3 or 0.667, however you want to write that. Okay, and before it is going up. It's got a positive slope. After it is going down. It's got a negative slope. So there's our sign diagram. Okay, oops, that's not A, but that's B. Okay, at what time is the anesthetic most effective? So obviously right up here at the top is where it's going to be the most effective, which is at 2/3 of an hour. So 2/3 of 60 means it is most effective 40 minutes in. Okay? Okay. Last one we're going to take a look at here is number 4. Oh, the boat and the seashore problem. Okay, I've seen these before. B is a boat about 5 kilometers out at sea from A. AC is a straight sandy beach 6 kilometers long. Peter can row a boat at 8 kilometers per hour, and then run along the beach at 17 kilometers per hour. Suppose Peter rows directly from point B to point X, so point B to point X along the shoreline here, such that AX equals X kilometers. So there's the distance, basically the distance from directly straight across on shore. Explain why X has to be between 0 and 6. X has to be between 0 and 6 because this is only 6 kilometers wide here, so he's not going to row his boat to shore over here, and he's not going to row his boat to shore over here. He wants to row his boat to shore somewhere between 0 and 6. And that's why it's got to be between 0 and 6 there. Okay, show that the total time Peter takes to row to X and then run along the beach to C is given by this whole thing here, where X has got to be between 0 and 6. Okay, so let's figure that part B out. Okay, so let's start off by figuring out some of these lengths in here. So we know that this is X, this whole thing is 6. So if this is X, like let's say this X is 2, we know this whole thing is 6, we take 6, subtract 2 to figure out what the distance is between x and c, right? So we're going to take this distance between x and c is going to be 6 minus whatever the x value is, right? And we have this is a right triangle. This is x, this is 5, so we should be able to say, hey, we know that x squared plus 5 squared has to equal this distance b to x. Let's call this r for the rowing distance, right? It's going to equal r squared. So we got we got x squared plus 25 equals r squared. So we'd square root both of those and get that r is the square root of x squared plus 25. So this is square root of x squared plus 25. If you can read that. Sorry, I'm kind of writing on an angle there. Okay, so we know those two pieces there show that the total. So what we need to know is we need to know this r distance and this 6 minus x distance here, right? Okay, so we know that this here distance divided by speed is going to be the time taken. Okay, so the time is distance divided by speed here, right? So the time it's going to take to go from b to x is going to be our distance, which in this case is the square root of x squared plus 25 divided by the speed. Now he's able to row at 8 kilometers an hour, so we'll take that and divide it by 8. And then for this piece here, this distance, same thing, time is the distance divided by the speed. So in this case, that distance is 6 minus x, and the speed that Peter is running along the shore here is 17 kilometers per hour, right? So our total time would be these two things added together, right? So time of x here we've got is our x squared plus 25 divided by 8 added to 6 minus x over 17, which is exactly what they have right there. Okay, so there's our total time there. Okay, I know they didn't ask this. Actually, this is, I think, part of part C. I know we're not officially doing this part, but I went through and put this here into the y equals and graphed it after I changed my my window to make it work. I went from -1 to 6. It should be from 0 to 6. I just like to see what's going on a little bit ahead of time. And then I just did y minimum. Really wasn't the big deal, but the y max was 2. Once I got the y max down small enough, I can actually see that it kind of bows down right here. So this is going to be our minimum time. So to find that, we would just do second trace, find the minimum, and that will tell you what the minimum time amount it would be to for Peter to, like, the minimum amount of time. So, but you can also tell by this graph here, it's got such a slight little curve in it is that it's not going to be a huge difference as to where he rows to shore. Okay. Anyway, okay. Sorry, that's all we have for the 12B Part 2 problems here. If you have any further questions on any of this, please feel free to ask in class.